All right, let's spend some time talking about the thing that's actually understanding what I'm saying right now, which is the brain, which is kind of cool. Like everything you ever thought, felt, imagined, that all happened right there. And it's the thing that you're constantly relying on if you want to do well on exams. So let's talk about how we organize it and what the different parts do. So we're going to concept map this out based on some major structures within the brain. So let's go with cerebrum first, because that's a part most of us are familiar with, and that's really the conscious part of the brain. So when you're looking at the cerebrum, the cerebral cortex is where you're going to have the lobes. So the lobes being the areas that are going to deal with a lot of the sensory information and decision making. Starting with all the way in the front, we have the frontal lobe. Think about this as the one for output. So this one's going to be the one that has your primary motor cortex. It'll have the motor association area. Because anytime you have a primary area, you will have an association area that helps it out. There are also some actions that we're doing that really require a dedicated space, typically just on one side. Because most of the brain, the way it works is what you're doing on the right side is actually to deal with the information and movement on the left side. But there are some things that are really kind of complex and we really want to make sure it's all coordinated correctly, like speech. So we have a speech area, so motor speech area. That's also known as Broca's area. Now, once I actually gave myself a concussion that was so bad that I lost that ability to speak because I had hit it on the left side, because that's typically where it's at, right over that motor cortex. And so the motor speech area, I knew what I wanted to say, but I couldn't actually coordinate all of the different things that we have to do to get speech to come out. So if you actually think about it, it's not just pushing air out of the airway and coordinating the diaphragm, it's knowing how tight to hold the vocal cords, the positions of the tongue, the way we move the lips. We kind of take a lot of this for granted, but it's a lot of stuff that you have to coordinate that actually have to coordinate both sides to do exactly what you want. Same with the eyes. We have a frontal eye field for eye movement. So you can scan across, say, for example, a concept map in a nice smooth way. So these are all dealing with output. Now, another really interesting thing, if you think about it as an output, is our personalities, our conscious decision making. That is an output. And so another thing that you will have in the frontal lobe is what we call the prefrontal cortex. This is the very front part of the frontal lobe. So if you're kind of looking at these in order, this is going to be the most anterior, this one coming around to be the most posterior. The prefrontal cortex is decision making. This is the part when you're talking to yourself, you're talking to your prefrontal cortex. When you're like, ooh, I should really study for anatomy, but you know what, the test isn't for another week, and like my friends are having a party and I kind of want to see them, I haven't seen them in a while. All those conversations that you're having up there, that's prefrontal cortex. Now, interestingly, prefrontal cortex is the last thing in the brain to finish developing. Not until like mid to late 20s do we finally solidify that area for making decisions, which really explains some decisions that I made when I was in my early 20s. So when you're looking at the output idea for frontal lobe, I think that one makes sense as belonging up there. Now, right behind the primary motor cortex, there is a divider. So we have a central sulcus. Remember, sulcus are where you go down in the brain. And so the primary motor cortex is the bump right in front of that divider for movement. The bump right after that divider on that post-central gyrus, because gyrus is the elevation, is going to be for general senses. So it makes sense. If you feel somebody touch your finger, then the area for moving that finger would be right next to it. So you're going to keep those general senses near each other. So off the front, or right after the frontal lobe, if we come back here, we have the parietal lobe. With the parietal lobe, you're going to have that primary somatosensory cortex we were just talking about. So that one deals with general senses across the body. So I like to think of those general senses as the ones that are coming from skin. Temperature, touch, pain, they're all kind of the same idea of general being the fact that you don't have one organ dedicated to it. It is widespread throughout the body. Anytime, as I mentioned, you have a primary area, you will have an association area. So we have the association area for the somatosensory cortex, then we call it the somatosensory association area. There's a lot to say. Now, parietal lobe, dealing with the general senses from your skin, you probably should coordinate what's happening if you put multiple senses together. So there is an area that overlaps between this lobe and some others, which is going to be our Wernicke's area. So with Wernicke's area, you're going to put information in from different lobes and different areas to figure out what's happening in that moment. It also contains the Gnostic area. And a lot of this is also interpreting communication, like understanding not just what you hear, not just the auditory information, but what do you see? What are the visual cues that come with that information? Because have you ever gotten into one of those fights where somebody sent a text message, but you didn't know how to quite interpret it because you didn't see their face to know that it was supposed to be sarcastic? This area puts those individual pieces of information together to come up with a full story and how to understand things. So it's also going to receive information from the temporal lobe because that deals with auditory information. So we'll have the primary auditory cortex. It does also have compartments of the Wernicke's because it overlaps between the two. Anytime you have a primary, you also have an association. So we'll have an auditory association area. And another interesting thing with temporal lobe, so it's over here by the ear, which makes sense, right? So so far we've gone frontal, parietal, now we've worked our way under temporal. There's another divider, sulcus here. So that's that transverse sulcus. It separates out the parietal from the temporal lobe. The primary auditory cortex is at the top there, association area underneath it. But if you go straight up and under, there's an area for smell. So your primary olfactory area is also off the temporal lobe. That's on the uncus, if you actually want to know the technical name for the underside on that temporal lobe, where you find that. Now, I've been talking about for all of the primaries, there's an association. Now, with your sense of smell, there isn't, because it's going to work really closely with a different lobe that deals with a different sense, because these two are tied so closely together. They're both interpreting chemical messages in the environment. This ones are the chemical messages that kind of swirl in the air and hit the receptors at the top of your nose. In the insula, so the insular lobe, you're going to have the ones where the chemicals touch the tongue. So this is going to be for taste. So you have a primary gustatory cortex. And again, it doesn't have an association area because these kind of talk and communicate and work together to kind of make sense of what's going on in their environment. Now your last lobe, which is the one that you're really probably relying heavily on right now, besides just temporal listening to me, is going to be your occipital, so all the way in the back. So if you haven't noticed yet, a lot of these lobes match the names of the skull regions, except for this one. Insula means island because it's actually kind of tucked in between these two physically. That divider that we just talked about here, if you crack that open, that's where you would find it. So if we look at the back of the brain, come back here, that's the occipital lobe. And that's the one for vision. So we'll have our primary visual cortex. I tend to remember that because I think the eye is kind of projecting to the back of the brain. And then we have the area that kind of keeps track of all those things that we've seen before, all the patterns. So if you see a clock that maybe you've never seen before, you can at least figure out its clock based on some of the matching patterns to ones you've seen before. So that's what the association area does. It really kind of keeps tracks of patterns and then remembers what things are. So you're storing your memories there. So we have our visual association area. So it's your association areas where you're spending time really kind of storing things in long-term memory. So as a student, why is that really useful to know? If you want things to stick, use multiple association areas. Use a lot of different types of modalities. So tactile, move things around, make puzzles. Auditory, talk things out, listen to videos. If you go to occipital, you're watching things, you're mapping things out, you're color coding, as you know I like. So that way you can work that memory into different locations. So in case you can't remember it from one, maybe you have a backup for another.